Hi friends, this is Cambridge IGCSE Physics 062541 May June 2019 question papers. We are going to solve all the questions here. The first question is about an acceleration time graph. It is about a rocket propulsion. So the rocket is stationary on the launch pad. At time t is equal to 0, the rocket engines are switched on and exhaust gases are ejected from the nozzles of the engines. The rocket accelerates upwards. The figure shows the acceleration time graph. First question, define acceleration. That we know it is a rate of change in velocity or change of velocity per unit time. Change of velocity per unit time is called acceleration, or we can write in the form of equation change in velocity over time, v minus u over t. Next question about the speed time graph. Speed time graph corresponding to the above picture. Sketch a graph to show how the speed of the rocket varies between t is equal to 0 and t is equal to tf. So here you can see the acceleration increases constantly. So the same thing if you represent here the speed time graph. Gradient of speed time graph is acceleration. As acceleration is increasing, gradient of this graph should increase. But after reaching some time, the acceleration is constant. So after reaching that, it will remain constant. So you can show like this. Gradient is increasing. Like this you can show. It is increasing, then become a constant value. So a constant value. So gradient was increasing. After some time, gradient is constant because acceleration is constant from the previous graph. That is why straight line, constant gradient. It is a 3-mark question. Okay. Then in C part of the first question, they are asking, sometime later the rocket is far from Earth. The effect of the Earth's gravity on the motion of the rocket is insignificant. Means there is negligible gravitational effect of Earth on the rocket. As the rocket accelerates, its momentum increases. State the principle of conservation of momentum. That we know if there is no external force acting on a system, its momentum remains constant. That is the principle of conservation of momentum. Or for an isolated system. For an isolated system. Isolated system means there is no force acts on it. System, its total momentum remains constant. Its total momentum remains constant if there is no resultant force acts on it. The meaning of isolated system is there is no resultant external force acting on it. Then explain how the principle of the conservation of momentum applies to the accelerating rocket and the exhaust gas. So as the gases are ejecting down, the rocket is accelerating up. So the rocket is accelerating means its momentum is increasing. The question is about conservation of momentum. So we can say rocket gains momentum in upward direction. So at the same time, the ejected gas will gain equal amount of momentum downward or opposite direction. It is 2-mark question. So we can say total momentum of the rocket upward and that of the gas downward. So we can say rocket gets or gains upward momentum. And by giving back equal momentum on the exhaust gases. So as well as the exhaust gases gains equal momentum downward or equal and opposite momentum. So total momentum remains constant because the equal momentum in opposite directions will cancel. So net momentum is 0 because there is no external force acting on them. Okay. So this is 2 more question. In second question, it is about moments. It is about moments, turning effect. So here figure 2.1 shows a sign. It is a signboard that extends over a road. So there is a support post we can see, and a signboard we can see, and there is a concrete block and some distances and weight they are showing, and a point P is also showing in the picture. The question is this: the mass of the sign is 3.4 times 10 to the power 3 kilogram. Calculate the weight W of the sign. We know weight W is equal to mg. So mass is given as 3.4 times 10 to the power 3 and g value is 10. So we will get weight is equal to 3.4 times 10 to the power 4 newtons. 3.4 times 10 to the power 4 newtons is the weight we are getting. Next question: the weight of the sign acts at a horizontal distance of 1.8 meter from the center of the support post, and it produces a turning effect about point P. So we can see a point P there in the picture. This is the point P. Okay, and the question: the point P is a horizontal distance of 1.3 meter from the center of the post, of the support post. Question: calculate the moment about P due to the weight of the sign. So from the picture we can find the distance between the point P and the direction of action of the weight of the sign is this distance. This is the whole distance of the weight from the post, and this is from the post to the point P. So this distance is 1.8 minus 1.3. So the distance between the P and the direction of action of weight is 1.8 minus 1.3 meters. Then we have to calculate the moment. Moment is equal to force times the perpendicular distance. So the force is the weight. So moment is equal to force times perpendicular distance. So the weight is found before 3.4 times 10 to the power 4 times this is getting 0.5. So the answer will get half of this. 1.7 times 10 to the power 4 unit is Newton meter is the moment. So the question is to find the value of moment of the weight about the point P is the question. Okay, then the next part: a concrete block is positioned on the other side of the support post with its center of mass a horizontal distance of 70 centimeter, means 0.7 meter from the center of the support post. State what is meant by the center of mass. Center of mass of any object is the point at which its whole mass is assumed to be concentrated. Center of mass of any object is the point at which the whole mass, the mass of the body is assumed to be concentrated or considered to be concentrated. Next question: the weight of the concrete block produces a moment about point P that exactly cancels the moment caused by the weight W. Calculate the weight of the concrete block. So we can use the principle of moments. Total clockwise moment is equal to total anti-clockwise moment. So in the question, the weight is making a clockwise moment about the point P, and the weight of this concrete block is making an anti-clockwise moment about the point P. So clockwise moment is equal to anti-clockwise moment. It is the weight of the block we have to calculate. this weight of the block we have to calculate. So this distance between P and the direction of action of weight of this block is this 0.7 meter plus 1.3 meter is total distance is 2 meter. 2 meter is the total distance. So the anti-clockwise moment is its weight times this 2 meter. Clockwise moment we already found, it is this weight we already found times this distance of 0.5 that we calculate already as this value, 1.7 times 10 to the power 4. So 1.7 times 10 to the power 4 is equal to WB times 2, weight of block times 2. So we can rewrite that equation as clockwise moment is 1.7 times 10 to the power 4 is equal to anti-clockwise moment is weight of the block times 2 meter. 2 meter we got by adding 1.3 with 0.7. So the weight of the block is equal to 1.7 times 10 to the power 4 divided by 2. So we will get, it is by using the calculator we can get the value as 8.5 times 10 to the power 3 newtons. 8.5 times 10 to the power 3 newtons is the value of weight of the concrete block. The question, the concrete block now it is removed. The concrete block is removed from here. So here the sign and the support post rotate about point P in a clockwise direction. State and explain what happened to the moment about point P due to the weight of the sign as it rotates. So we know there is a block. Due to this block it is balanced with this weight action. After it is removing, the only moment is due to the weight of the signboard. So it has a tendency to turn clockwise this way. Then the question now it is, as it is turning, what will happen to the moment due to the weight of the sign? So we know as it is turning, these two distances, distance between P and action of weight will increase. So moment due to the weight of the sign also will increase. This distance here it was 0.5 meter. After it is turning, this position will change this way. So it will come this way. So weight will act this way. So the distance increases more than 0.5. As the distance is more than 0.5, moment also will increase because weight remains same. So we can say as it turns, distance between P and weight of sign increases. So the clockwise moment will increase. So the moment due to weight of sign about P will increase.